Alrighty, so we're going to continue on with section 7.4, partial fractions. We are on part 5 now. Before I begin this section, I want to write down an integration formula that we're going to need here. It's the integral dx over x squared plus a squared. This is going to be, you can do a trig substitution if you want to work this one out yourself. It's a good practice problem. This is the arctan of x over a plus c. So we're going to need that in this section, and the reason being, so up until now, so everything we've done has been linear factors. So they've always factored as like x plus a, to some power. So the question is, what if a factor is nonlinear and irreducible? I mean over the reals again. So that just means I can't use complex numbers here. So I'm going to box this because I want to make sure that I see it when I come looking for it again. Okay, so we have a nonlinear and irreducible factor. So what that means is, if I had a factor like x squared plus 2, sorry, x squared plus 1, x squared plus 2 works also, but this is easier to think about. So you might say, okay, if I want to factor this, is it able to do that with real numbers? And the answer is no. So the idea is, even though I can write this as x plus I times x minus I, if you're, comfortable with complex numbers, I'm not going to worry about that because we aren't talking about how to integrate with, with complex numbers here. We're doing our integrations with real numbers. So we don't want to consider factorizations like that. So what we're going to do then is we're going to say, okay, if I have a rational function that looks like this, and I'm able to factor out, a form that looks like ax squared plus bx plus c, where this is irreducible. So it doesn't have real roots is essentially what that's saying. The roots of this thing are not real. So what this means is I'm going to get, a factor that's going to look like this, ax plus b over ax squared plus bx plus c, while I'm doing my partial fractions decomposition. There might be other factors from the other, whatever's in this q of x. But, this ax squared plus bx plus c contributes to the first factor here, the ax plus b over ax squared plus bx plus c. So let's jump into an example of where we're going to see this. So let's do this. We have the example. So we want to evaluate the integral of 2x squared minus x plus 4 divided by x squared plus 4x dx. X cubed plus 4x dx, sorry. First thing we're going to do is we're going to try and factor the bottom as much as we can, so the denominator. So if we factor out an x, I'm going to have x squared plus 4 down there, dx. Now if you look at that x squared plus 4 term, that one doesn't factor any further. Its roots are not real. And that's what we're checking. We're checking if this thing has real roots. If it has real roots, it can be factored with real numbers. If it doesn't have real roots, it cannot be factored with real numbers. So what we're going to do now is we're going to do partial fractions on this. 2x squared minus x plus 4 over x squared plus 4. And so, from this x factor here, I'm going to get, a term that looks like this, a over x. And then from this factor, the x squared plus 4, I'm going to get a term that looks like bx plus c over x squared plus 4. And now I'm just going to do my usual partial fraction. So the whole point of this example is I now have this new term that looks like this. But you're going to see, and it comes from this 1 over x squared plus 4. But you're going to see that this doesn't affect how we're going to do anything else. I'm going to just follow all the same steps that I did before. I'm going to put the right-hand side over a common denominator. So if I do that, I'm going to get a times x squared plus 4 times, or plus, bx plus c times x. Common denominator is already given to us on the left-hand side. That's what I'm trying to get there. So I'm going to have x times x squared plus 4. And now because my denominators are the same, I can multiply them over. They cancel out. We'll be left with 2x squared minus x plus 4 is equal to, I'm going to go ahead and expand the right-hand side, get ax squared plus 4a plus bx squared plus cx. And now again, so this is, I'm following all the same steps that I've been doing. Left-hand side stays the same. Right-hand side, I'm going to start collecting, powers of x squared. So if I put those together and factor out the x squared, I'm going to be left with x squared times a plus b. I don't have anything to factor with the cx, and the constant term is just 4a. So it's going to be written like that. And now what I'm going to do is I'm going to compare coefficients. So the coefficient, because I want these two polynomials to be equal. Coefficient in front of x squared has to be, on the left-hand side, has to be equal to the coefficient in front of x squared on the right-hand side. So that gives me the equation 2 is equal to a plus b. If I look at the coefficient in front of x on the left-hand side, that one is -1. So that has to be equal to the coefficient of x on the right-hand side. That's just c. Same thing for all the constants. All the constants have to be equal to each other. So 4 is equal to 4a in this case. So I'm not going to do the algebra. This one is actually straightforward. So we're going to get a is equal to 1, c is equal to -1, and then that'll also give us that b is equal to 1. And that tells me, so the reason I do that again is because I want to know what a, b, and c are here. Now I can, expand that. So what that gives me is that, so I'm going to have 2x squared minus x plus 4 over x times x squared plus 4. This is going to be equal to, so a over x, so 1 over x, plus bx plus c, so bx is just x, plus c is -1, all over x squared plus 4. And now I can do this integral, because now the integral of 2x squared minus x plus 4 over x times x squared plus 4 dx is going to be equal to 1 over x, the integral 1 over x plus x minus 1 over x squared plus 4 dx. And now I just do that integral. So I'm going to split it up into 3 integrals. So I get the integral 1 over x dx. I'm going to split the numerator of the second term here, the x minus 1 over x squared plus 4. This is going to give me the integral of x over x squared plus 4 dx minus the integral of 1 over x squared plus 4 dx. So this first one is pretty straightforward, ln of the absolute value of x. The second one, if you need a u substitution, do it. I can do that one in my head. I'll leave it to you because you guys need to practice more than I do. It's 1/2 ln of x squared plus 4. This last one is the form that I've written at the very top of this page, which I'm going to go up to now. So at the top of this page, I wrote down integral dx over x squared plus a squared. It's 1 over a arctan of x over a. So if you look down at in the notes, it's x squared plus 4. So a squared is 4. So that tells me a is equal to 2. So this is going to give me, so this last integral, the 1 over x squared plus 4, is 1/2 arctan x over 2 plus my integration constant. Oops. So let's do that. And that's going to be my answer for this integral. So again, if you don't see the second integral, how I got that is a u substitution. Check it out. You guys need to do that more than I do. So get rid of that. I meant to be doing that from there. So that's how you're going to do this. But I want to point out that, this was a really nice one because when I factored this, I got like an x squared plus 4. But, I could have gotten something much worse. I could have gotten something like x squared plus x plus 4. And that's going to be a little bit of a harder problem. So I'm going to start that on a new video just because I've made, I think, 4 of these videos now, and I've made some stupid mistake that has made me have to restart these videos, which is very frustrating. So I'm going to stop here, and I will do that next example where we don't get a nice x squared plus something in the denominator, and we'll talk about how to tackle that. So let's stop the video here. This will be a short one.